Alright, in this video, hopefully rounding out the characteristics of functions, depending on what order you are watching these in. But maximums and minimums, most functions have them. We are lucky that we have the two we do this year because there's something special about those two, linear and exponential. So, basically, common sense, maximum is the highest point, minimum is the lowest point. We're looking on a graph to see where that happens. So, with this example here, another funky function, but it's a function nonetheless, passes the vertical line test. But we want to ask ourselves, what is the lowest possible point on this function? What is the highest possible function point? And it kind of relates back to your range, because range is lowest to highest y value, which is what we're talking vertically here. So your lowest possible point that this function reaches is right here, and the highest possible point is here. And we actually reach those. Those are something that is reachable. We could draw it on our paper. So we say that this one here is an absolute minimum. And the one up top is an absolute maximum. Because there's, when we say absolute, that means there's nothing that can be above it. There's nothing that can be below it. So if you notice, there is no other point beneath this one down here. It's the absolute minimum value. There's no other point above this one. It's the absolute maximum value, the biggest one we can have. Now, some of you are probably looking at this other fine point that I've put on here and are like, well, that's a minimum too, and it is a minimum, all right, but it's not the absolute minimum because it has a point lower than it. The one we were just looking at is lower than that one. So this is a minimum, but we call this one a local minimum. Alright, so if you hear that word local, that just means within this area of the graph, localities, locations, that it within reason is the lowest point. However, when you take the graph and look at it as a big view, you're looking at this whole function, then you have absolute maxes and mins that kind of knock this one out of the running for a maximum, an absolute maximum or an absolute minimum, that is. So the way we write this, we're going to say that we have a max, and you want the y value, a max of, what is that, max of 6, so we're looking at this point, max of 6, maximum value of 6 at what x value, and let's see, that would be 1, 2, 3, 4, 5, 6, so max of 6 at x equals 6, so basically kind of tearing this point apart. This point is 6, 6, and there's your 6 and your 6. So a maximum of 6 at x equals 6. And then we have a minimum, or absolute minimum, of, and again, y value first, minimum of negative 8 at an x value of negative 8 again. 1, 2, 3, 4, 5, 6, 7, 8. Yep, not intentional. So this point is negative 8, negative 8. And again, there's your negative 8, negative 8. We're just kind of ripping it apart into its y values, which are these. And then, of course, these are labeled that way, but they are x values. So a maximum of 6 at x equals 6, minimum of negative 8 at x equals negative 8. Now, you could do the same thing and list these the same way for your local stuff, but right now we're just going to talk absolute. All right, crazy graph time. Notice this side of the graph has an arrow. That means we are going to keep going on forever and ever. So, while this point over here, hopefully you're seeing is an absolute maximum, there's nothing higher, we can't call this arrow where it's stopping or wherever you're looking at it as the minimum because this graph goes on forever down like to negative infinity. We don't ever stop. So, as far as a minimum, since we're pointing toward negative infinity, that means we're going to keep going and never stop. That means there is no minimum. But our maximum we do have. We have a max of 2 at x equals 9. So again, this point, ripping it apart, 2, 9. So no minimum because this arrow says we keep going forever. And if we're going on forever, negative infinity is where we're approaching, but since negative infinity is not really a number that we can reach, we can't graph it, then we're not ever going to write it as a minimum or a maximum if it's going the other direction. All right. So this one, hopefully you're seeing this one immediately as your absolute minimum. So we have a min of -4 at x equals -2. So there's your point, -2, -4. But notice both of these ends have arrows as far as our maximum. Since these are both pointing up, there's no stopping point on either side of this graph. So we're going to keep going to infinity, but again, infinity is not a number we can reach and touch and graph. So there is no maximum. We're going to keep going on forever. All right, now getting to our functions for this year. All right, when we're talking mins and maxes of lines, both arrows are going on forever. That means toward infinities, negative and positive. That means we will never touch a stopping point in either direction. So as far as these go, there is none of either. Pretty easy. Check this one out. Your other function. All right, this one obviously is pointing up toward infinity. We're never going to reach that. So there is no maximum. This is going to keep going up forever. So we can go ahead and say max is none. But some of y'all's eyeballs are saying, oh, the minimum's 0 here because we're getting close to 0. But think back to what this asymptote is. This is an invisible boundary line that we can never touch. We can get really, really close to it, and we could continue to get close to it if we had the computer capacity and graphing capacity to do so. But since we can never fully touch this boundary line, this asymptote, while you're approaching 0, you're never going to get to 0. So do not put that the minimum is 0. That is wrong. All right. In this case, just like with our lines, there is none. All right. So don't go get crazy with exponentials. You're approaching a number with that asymptote, but you can never fully touch it. It's just something we're getting close to. All right, and another one to practice, just in case, because these are the ones that are going to throw you. Here's your asymptote that we're approaching. So while some of y'all are going to be tempted to say that this is approaching -6 as a minimum, there is no minimum because this arrow says we just keep getting closer and closer to this line. So there's no min and there's no max, so we just write none for both because this arrow goes on to infinity. All right, so quick little practice. Don't pause too long. Linear functions and exponential functions blank have maximums or minimums. These are our two focus points, so we're not going to go do some crazy functions. If you want to go try the examples again, you can. But these are the two you're responsible for this year, and they have something special. So pause it for like literally 2 seconds to fill in that blank and check your answer. Never. They are never going to have maxes or mins, so please keep that in mind. Those are easy points to grab. All right, until next time, keep practicing.